Hello everyone, let's solve today's POTD for the November. So the question is delete characters to make a fancy string. A fancy string is a string where no three consecutive characters are equal. Given a string S, delete the minimum possible number of characters from S to make it fancy. Return the final string after the deletion. It can be shown that the answer will always be unique. Let's understand the examples. The input given to me is LEETCOD. So here, as they stated in the question, that there should be no three consecutive characters which are equal. Like here, we can see that there are three E's, EEE. So according to questions, in my answer, there should not be three consecutive letters. So I have to delete one. So we have deleted one, and then there's no other consecutive three characters, so we just return the lead code after deleting one E. In the second example, as we can see here, we have 3A, then B, then 4A's. So according to question, we cannot have three consecutive letters. So from these three, we have deleted one A. From these 4A, we have deleted only like two A's to make it less than three. Okay, so and in example 3, we have AAB. It is satisfying the condition given in the question, so we will not change anything and we'll just return it as it is. So we can have like we what we can do is we can have a counter, and we can count for each element, like whenever we are getting some element, so we can have a counter which will count its occurrence and will remove if we get more than three count, something like this. But if we try to remove element from the string given itself, it is going to give TLE, because as we can see the constraints here, it said its length should be it will be from 1 to 10 raised to power 5. So if we remove element from the given string, what will happen is that when we will use the erase function, it will give the extra overhead, and it will increase the time complexity, so it will give TLE. So what we will do is we will make another string, and we will add only those elements which are needed. Like we will only add less than three elements, so it will have less time complexity. So let's implement that now. Okay, so let's have a string result in which we will store our result, and let's have a counter, and let it set to 1, because we will store first element in our result only, because then we will have a check from the second element. So that's why I've set counter to 1. Then in result, just push back the first element, and since I've first element in my string, that's why the counter is 1. Okay, so now let's start the for loop from I int I, from 1, I smaller than s length, I plus plus. Okay, now let's check if my s of I is equal to s of I minus 1. So if my current element where I am at, like from this I have stored L in my result itself, and if my second element is equal to the first element, it means I have to increase my counter. It means I've got like the same element, so I'll increase my counter. Else if I didn't get the same element, I'll reset my counter to 1 again, because its counting is over. I have only one L now, I'm at E, so I'll start counting the next element. I'll set my counter to 1. Then if my counter is smaller than 3, then I will just push back the element which I am at, because it is less than 3, so I can have that element s of I. And in last, just return your result. That's it. Okay, let's submit it. Yes, yes, all done. So looking at the time complexity, it will have a time complexity of big of n, the size of the string, because we are traversing in the string, and increase in the count variable will take constant time. So the time complexity will be big of n, and space complexity is the size of the string result. Yeah, thank you.